Hello, my wonderful math students. I hope everybody's well rested and that we're kind of ready to tackle today's problems. So just a brief overview of how this is going to look. Basically, the ministry is telling us, so the government is telling us, that you should expect to do 3 hours of work per subject per week. So if you're taking 4 classes right now, if we were at school during the day and you were in 4 classes, you're looking at doing 12 hours of schoolwork a week. So I know that some of you will probably be able to do this in probably less than 3 hours, and some of you might struggle to do this in 3 hours. So here is my expectation. I'm going to post a video, 3 videos every week for you to watch. Those are your lessons. I'm going to post handouts, and you can print them out if you wish to and fill them in. You don't have to do that. And some questions for you to practice. And throughout the week, my expectation is that you are checking in with me at least one time. So you're checking in with me one time before the week is over. So from Monday to Sunday, I should hear from each of you one time. Okay? And you can do this by emailing me. And in this check-in, you're going to let me know how the learning is going. So you can email me here. And then if we need to, I can record some more meetings, or we can have some sort of like virtual meeting on us taking up some homework questions. Okay? Sound good? All right. So in these videos, it's going to be almost exactly the same as how we were doing them in class. You're going to have a warm-up. Here's what I'm doing. I'm focusing on the most important things that you need to know for next year. Okay, so these are the skills that you 100% will use next year in grade 11 math. So my warm-up today is let's talk about these fractions, and we've all talked about fractions before, so we're adding together fractions in my first question. So notice that's 1 over 3 plus 2 over 4. That's the question. I know that I've put some things in there, just ignore those right now. So 1 over 3 plus 2 over 4. And whenever we are adding fractions together, so if you know how to do this, pause the video, try to do the questions, and then you can listen to the explanation. So we know how to add fractions together. And whenever we add fractions, so if we're adding fractions, you need a common denominator. Okay, that's awesome. We can do that, no problem. Okay, so we need a common denominator. So if I'm looking at this, a common denominator, so the denominator is the bottom portion of the fraction, so my 3 and my 4 here, these are my denominators. My common denominator here is going to be 12, because 3 and 4 can both go into 12. Okay, so I'm going to ignore my second fraction for now. I'm going to ignore this second fraction for now. Just look at my first fraction. How do I turn this 3 into 12? Well, I turn this 3 into 12 by timesing it by 4. Whatever I do to the bottom, I have to do the top. So I'm going to do 1 times 4, 3 times 4. Okay, well, how do I turn this 4 into 12? Well, to times it by 3. Whatever I do to the bottom, I have to do to the top. So my next line is now going to look like this. What is 1 times 4? Well, that's 4. And what's 3 times 4? Well, that's 12. Okay. What's 2 times 3? That's 6. What's 4 times 3? Well, that's 12. We're going to pause and check. Are both of my bottom numbers, both of my denominators the same? Yes. Math smiley face. That means that I'm going to add the tops. So I'm going to do 4 plus 6. I'm only adding the tops here. 4 plus 6, that's 10 over 12, which was my bottom. Okay? All right. Now, 10 and 12 both have a number that's the same. Okay, so something can go into both of those. That's 2. So I want to write this in lowest terms. So to do that, I'm going to divide the top and the bottom by 2. 10 divided by 2 is 5. 12 divided by 2 is 6. Okay, this is my answer. All right. So again, if you need to go back, pause, rewind, go back and listen. I'm going to turn off my laptop sound, sorry. So when I'm multiplying fractions like this, I do not need a common denominator, so I don't need a common denominator here. What we're going to do, and I'm going to show you two ways to do this. The first way is I'm going to multiply my tops with my tops. Okay, so I'm going to do 2 times 6. And then I'm going to multiply my bottoms with my bottoms, so 5 times 2. 2 times 6 is 12. Sorry, this is times. 5 times 2 is 10. Okay? Okay, well, I have 12 over 10. I'm fine with you leaving it as a mixed number, but we should reduce it. So we can divide both of these by 2. So that's going to be 6 over 5, because 12 divided by 2 is 6. Okay, 12 divided by 2 is 6. 10 divided by 2 is 5. All right, that's my answer. That's my first way of doing it. So way number 1. Number 2 is to reduce before I multiply. So if I have my question like this, 2 over 5 times 6 over 2, what you can do is you can look at your opposite. So I'm going to look at my 2's here and my 5 and my 6. And I'm going to say, hey, can anything go into both my 2 and my 2? Well, 2 and 2 are the same number. So I can cross those off and replace them with a 1 because they're exactly the same. Is there anything the same that's between 5 and 2 or 5 and 6? No, there's not. So now I'm going to do my multiplication, but I'm going to use the new numbers that I've put in. So I cross this off and put a 1. Well, 1 times 6 is going to be my new numerator, my new top. 5 times 1 is my new bottom. 1 times 6 is 6. 5 times 1 is 5. See how I got the same answer? Check, check. Math smiley face. Okay, so this is your warm-up. So we're going to go to the next slide right now. Hopefully your brains are starting to think about math again. Okay, so today we're going to talk about how to collect and expand like terms. So we're going to learn something called the distributive property. Okay, and we're going to collect some awesome like terms here. All right, so that's our goal today. So in order to collect like terms, we need to understand what the idea of like terms is. So like terms are anything that have the same variables and same exponents. So let's talk about what that means. Same variables, same exponents. So basically variable, remember, is our letters. So we need to have the same letters and same exponents. Okay, so same numbers that are on the top there. You can only add or subtract. So again, this is super important. We can only add or subtract like terms. So it's like I can only add or subtract apples from apples. I can't do apples and oranges. That's weird unless I was looking at a fruit salad, which is not a real thing in terms of math. So let's talk about this. So if I'm going through this list and I'm looking at here, so 7x and negative 5x. Okay, let's look at this. Do they have the same letters? Well, yes, they both have x's. Do they have the same exponents? Yes, neither of them have an exponent. So this is awesome. This is a like term. Okay, let's look at the next one. 10x squared and 24x squared. Do they have the same letter? Yes, they both have x's. Do they have the same exponent? Yes, they both have these little 2's. Okay, these are like terms. It doesn't matter what the big numbers are, but the letters and the tiny numbers, those exponents, are the exact same. Let's look at the next one. 3xy and 7xy. Do they have the same letters? Yes, they both have x and y. And yes, their exponents are the same. Okay, they don't have one. Next one. 5x squared y. Well, if I'm looking at this and 3x squared y, do they have the same letters? Yes, they both have x. They both have y. Do they have the same exponent? Yes, the x has a 2, the y has no exponent. This is still a like term. They both are looking the same. X and 4x. Again, let's look at this. So yes, they both have x's. They both don't have an exponent, or we can't see that exponent. So these are the same as well. Okay? These are all what we're going to call same variable, same exponent. Okay, let's look at these other ones. All right, so let's look at not like terms. So 7x and 5. If I'm looking here, they do not have the same letter. This one has an x. This is no letter. This is not a like term. x squared and x. Notice that I don't care about the number that's in front of them right now, but just the letter. So yes, they both have the same letter, that's good, but their exponents are different. This one has a 2, this one doesn't have an exponent. So no, it's not a like term, right? 3xy, 7yz. Okay, well, they both have a y, that's great, but the other letters are not the same. So no, this is not a like term. And all the way down this list. Okay, so if I'm looking at these do not have the same variables, they do not have the same letters or the same numbers, okay? Okay, so now that we know what like terms are, we need to know that we can only add or subtract like terms together. So what that means is that I can only add or subtract things that have the same letter, same exponent. Okay, so my first step, I'm going to look at this first one, A, and I just want to go through, I'm going to underline all of the like terms with the same color. So everything that's the same like term is going to be the same color. So my 4x, I'm going to start by underlining that. Okay, that's the same as 2x, same letter, same exponent. That's the same as this 1x here. Okay, so that's single x there, same letter. And then if I'm looking at my 3, okay, that doesn't have a letter, that's okay. This doesn't have a letter, awesome. And this one also doesn't have a letter. So you guys see how those are like terms? My x's are all the same letter, same exponent. My numbers are all the same because they don't have a letter. So these are all of the things. So what I'm going to do now is I'm going to rewrite this next line so that all of my like terms are beside each other. Okay, so I'm going to take my 4x, my minus 2x, and my plus x, and I'm going to write those all, and actually I'm going to write this a little bit thinner, I think. I'm going to write those all right beside each other just so that I can see my like terms together, okay? And what other color did I use? Okay. So all of my x's are together, all of my numbers are together as well, and now I can add all of my like terms together. So 4x minus 2x. Now, we haven't really talked about this much, but all that matters here is my number in front of my x. Think of x like a unit, like centimeters, okay? I can do 4 centimeters minus 2 centimeters, that's fine. So 4 minus 2 is 2. I'm going to write the unit or the letter right beside it. Plus x. Okay, 3 minus 1, okay, I know that. That's positive 2 minus 6. Okay, so again, I'm going to do this again. My x's are just like that unit, like centimeters. So here I have 2 x's plus 1 x. Okay, so 2 centimeters plus 1 centimeter. That's going to be 3 x's, right? And 2 minus 6, so remember that negative 6, that's bigger than my positive 2, so I'm going to be in the negative here. And 2 minus 6 is 4. Okay? Now, notice, I'm not pushing anything else together here. This, 3x minus 4, this is my final answer. So I'm going to do math smiley face. Check. Math smiley face. Okay? My final answer. It's okay to have letters and numbers in my answer. Okay, all right. So let's skip B for now. I mean, it's exactly the same. Let's just go to C. I can tell that you guys are probably getting bored with all of this. So let's go to C. Again, it's exactly the same. So I'm going to underline the things that are the same. So I'm going to find all of my letters that have a K in it. Okay, so K and K. And all of my terms that have a T in it. T and T. And now I'm going to write them all together. So I'm going to write this. I'm going to put my K's all together. K. I'm going to do minus 6K because that's the sign that's in front of it. Minus 5T plus 2T. Notice that my signs that are in front here are the exact same as what was in front here. Okay, now I'm going to add or subtract them together. Add or subtract them together. So K, so this is a 1. If you don't have a number in front of them, feel free to write that invisible 1 there. 1 minus 6, that's negative 5. The K comes along for the ride. Negative 5 plus 2, well, that's still negative 3. The T comes along for the ride. Okay, this is good. I can't put K's and T's together. Check mark, math smiley face. So today's lesson is that you're going to go through and you're going to try to add and subtract like terms together. I've put a practice sheet on the Google Classroom. Please try to do them. Start by doing every other one. That's fine. You don't have to kill yourself here. And good news is that this is going to count towards that learning that you're doing. So you're just going to work at your own pace, right? 3 hours per week. That's what we're aiming for here. And so you will have 3 lessons on your Google Classroom. If you have any questions, please make sure that you send me an email, ask for help. I can do another video. I can slow it down. Go back and watch this video. Try to kind of work it out. Use a calculator. Make sure that when you're using the calculator, you're putting in the signs correctly, and everything should work out. It's okay to have letters in your answer. You're not just going to have numbers here. All right? You guys got this.